All right, here we go. So in our first problem, we're asked to find the equation for the line parallel to the line 3y minus 4x equals 15, and we want it to go through the point 9 comma negative 2. So first things first, if we're going to find a line parallel to this guy, we need to find the slope of that guy. And there's no better way to find the slope than to go ahead and put this guy into y equals form, because then we'll be able to find the slope and the intercept really quickly. So let's add 4x to both sides. We get 3y equals 15 plus 4x. Let's divide both sides by 3. That's going to yield us a nice y equals equation. Excuse me. We get y equals 5 plus 4/3 x. So my claim is that the slope of this original line is 4/3. And I'll even write original slope and not just slope. And so the slope of our parallel line, and I'll do our parallel line in green, well, parallel lines have the exact same slope. So the slope of our parallel line is also going to be 4/3. So now we need to find a line with a slope of 4/3 going through the point 9 comma negative 2. Well, if we know the point slope form of a linear equation, the whole y minus y1 equals m times the quantity of x minus x1, well, our x1, y1 in this case is just 9 comma negative 2. So we can go ahead and substitute those in for their respective variables in the equation. So we get y minus negative 2 equals our slope 4/3 times the quantity x minus 9. And this is fine as is. You may be asked to put this in a slope-intercept form, so all you really need to do is go ahead and solve for y. So we've got y plus 2 equals, now remember we're going to have to distribute this 4/3 to both the x and the negative 9. So we get 4/3 x minus 36/3, and I'm keeping that as a fraction, even though, well, actually we don't have to write that as a fraction. 36/3 is the same as negative 12. So we end up with minus 12. Let's subtract 2 from both sides, and we end up with our final equation, y equals 4/3 x minus 14. And this line is going to be parallel to our original 3y minus 4x equals 15, and it's going to also contain this point right here. All right, in our next example, what we need to do is we need to find the equation for a line not parallel anymore, but perpendicular to this guy. All right, even so, if we're going to find a perpendicular line, we need to find this guy's slope. So let's go ahead and put 2y plus 5x equals 12. Let's put that into y equals form to find the slope. So we subtract 5x from both sides. We end up with 2y equals 12 minus 5x. We'll divide both sides of the equation by 2. We end up with y equals 6 minus 5 halves x. So our original slope is going to be negative 5 halves. Now, hopefully we know at this point that if our original slope is negative 5 halves, our perpendicular slope is going to be the negative reciprocal of this negative 5 halves. So the negative reciprocal of that, well, the reciprocal will be 2/5, and we're going to switch the sign from negative to now positive. So we don't really put anything here, but I'm going to put a big positive there just to make that really clear. So now we've got our slope. We know the line, the point that we'd like this line to go through. Let's go ahead and we're going to use our exact same point slope form of a linear equation that we used before, except this time our x1, y1, if you will, is negative 4 and 5, respectively. So our equation is going to be y minus 5 equals 2/5 times the quantity of x minus negative 4, so x plus 4. And perhaps we need to go ahead and solve for y, and if so, we're just going to go ahead, y minus 5 equals, make sure to distribute that 2/5, so we get 2/5 x plus 8/5. Last thing we got to do, let's go ahead and add that 5 to both sides. 5 is the same thing as 25 over 5, because we know we're going to have to add fractions. And we end up with y equals 2/5 x plus 33 over 5. And this is the equation of a line who is perpendicular to our original 2y plus 5x equals 12, contains the point -4, 5.